Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam FM, the Financial Mathematics, and this is a problem for May 31, 2018. I previously posted it in a PDF file as exercise 16 for exam FM. On September 3rd, 2005. It's a problem from May 2005 Society of Actuaries Course 6 examination, which was an investments exam, and some material from that exam is now on the exam on financial mathematics. You are given the following with respect to Treasury securities as of today, May 13th, 2005. And we have 4 securities. The first 2 are zero coupon bonds with 0.5 years to maturity and then 1 year to maturity, and the yields to maturity, which also must be either for the spot rates, effective annual rates for half a year and for a year, are 3% and 3.2%. And then bond C has 1.5 year to maturity, has an annual coupon rate of 6%, but the coupon is paid semi-annually, so it's really 3% per half a year. And then the yield to maturity on that bond is 3.5%. And then bond D has 2 years to maturity. Annual coupon rate paid semi-annually is 5%, so it's 2.5% per half a year that is paid. And the yield to maturity effective annual is 3.6%. Calculate the 1 year forward rate 1 year from today. So immediately, as I said, we see that the spot rate from time 0 to time 0.5 is 3% per annum. It's the annual rate, even though it's a half-year bond, but the rate is annualized. That's how it's presented in the problem. And from time 0 to time 1, it's 3.2% per annum. If we assume $100 par, then security C pays coupons of 3 at times 0.5, 1, and 1.5, as well as its principal of 100 at time 1.5. Given that C's yield to maturity is 3.5%, if we write S1.5 for the spot rate from time 0 to time 1.5, annual effective rate, we get the cash flows on the left-hand side. We discount the cash flows using spot rates applicable for the times of the payments of cash flows. So the rate for 0.5 years for the first payment of 3, the rate for 1 year for the second payment of 3. Of course, for the first one, it's 1.03 to the 0.5 because 3% is the annual rate and the cash flow comes at time 0.5. And then 103 is paid at time 1.5, and we discount it at the spot rate applicable to time 1.5. So 1 plus S 1.5 to the power of 1.5. Now the right-hand side are the same cash flows, but discounted at the yield to maturity, and it's given for this bond. So based on this, we calculate its price, which is 103.667174, approximately 103.67. So using that price, if we subtract the present value of the first 2 cash flows using spot rates, we must get the expression for 103 divided by S1.5 to the power 1.5, and this comes out to be about 97.8042094. From that, then we just calculate 1 plus S1.5 to the 1.5 as 103 divided by this 97.80 and so on. And then we can calculate S1.5, and it comes out to be approximately 3.510988%. And now we do the same analysis for the spot rate from time 0 to time 2, denoted by S2, and security D. So on the left-hand side, we have the cash flows discounted at the spot rates applicable to the times of the cash flows. And the first three terms, if we just calculate them and add them up, are equal to 7.25969239. The last one is 102.5, the final maturity payment of this bond divided by 1 plus S2 squared, because it comes in 2 years from now. And then on the right-hand side here, we write out the same cash flows and discount them at the yield to maturity. And again, remember, yield to maturity basically means one interest rate such that if you use it to discount all cash flows of a bond, you get the price of the bond. Well, that's what we do here, and we get the price of the bond to be 102.740353. And as you can see, this amounts to an equation in which S2 is the only unknown, so we calculated from this, and this is the result, and S2 comes out to be about 3.610609%. Now, since the spot rate from time 0 to time 1 is S1 equal to 3.2%, the forward rate F12 from time 1 to time 2 must be equal to 1 plus S2 squared over 1 plus S1 minus 1, because you can also write it out first if you want. It has to be that the quantity 1 plus S1 times the quantity 1 plus F12, that has to be equal to 1 plus S2 squared by definition of what a forward rate is. So we plug in the numbers that we have for S2 and S1 and do the calculation, and we get F12 to be approximately 4.022851%, which is answer E. Please remember, this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.